Now let us start with the session on SAP HANA installation and its post steps. So basically in this session we will be understanding what are the preparation requirements needed for installing a HANA database server and how do we install it after getting the preparations ready, and after installation what are the needed post steps so as to configure the SAP HANA for productive use. First, let us start with installation preparation. Basically, what do you mean by installation preparation? In layman language, for any installation or any implementation, we have to prepare the hardware and also get the necessary software package and then proceed with the installation. So, on similar lines, for implementing an SAP HANA appliance or a server, we require right planning for achieving the desired performance of the product. Unless we prepare the hardware and install the software package in the right way, we cannot achieve the desired performance of the product. So, what are these preparation steps so that we can proceed to install SAP HANA software? Step 1 is firstly we need to refer PAM. PAM is called as Product Availability Matrix, which is a part of Service Marketplace. So we need to refer PAM for SAP HANA installation so that we can choose a certified and supported hardware to proceed with the installation. And this is the URL where we can navigate and look in for the supported operating systems. So once we navigate to this URL, we have to search for the product SAP HANA Platform Edition 1.0, and from there that will list the supported operating systems. So we will get to know the supported operating system releases which can be used for installations. So that's the first step. Once we have decided which operating system has to be used for installing SAP HANA database server, next step is about designing or about sizing the hardware so that we can proceed with the installation. What do you mean by sizing? Sizing basically means sizing the server with the needed hardware like CPU, memory, and the storage disks. In SAP HANA, sizing is mainly based on the required main memory. From required main memory, we mean the amount of data, the productive data to be kept in main memory is measured so that we can design the main memory according to that. Main memory is nothing but RAM. So RAM sizing basically depends on the amount of productive data the system should carry. This can vary based on the scenario the system is going to be used. For BW it is different, for SAP Business Suite systems it is different, for NetWeaver it is different. So based on the scenario of implementation, the size of the main memory can vary. And main memory sizing is basically dependent on static data and dynamic data. Static data means static RAM size and dynamic data means dynamic RAM size. So by static we mean that the size of RAM, that is amount of main memory that is used for holding the table data, these are static in nature. No doubt the changes are done on these data, but they are the table structure data. Coming to dynamic data, which is the dynamic RAM size, this is the additional memory required for data loading and query execution. And this by design is measured as equal to static RAM size requirement. And by dynamic sizing, we reserve it for data loading and query execution. So this dynamic RAM size is mainly for design time usage. During design time, we will develop new objects to do data loading into them, and we do query execution. So for all these purposes, we need dynamic RAM size. And going further, so now we have understood what is main memory, how does the sizing of main memory take place. Here are some of the recommended SAP notes provided by SAP for an administrator to refer so that right sizing of the server can be achieved. For example, note 1514966 explains about sizing of SAP HANA appliance. So if it is a standalone database, how the sizing should be is explained in this SAP note. And further on, SAP notes like 1944799 explains guidelines for SUSE operating system installation. So for SAP HANA installation point of view, how SUSE operating system, SUSE Linux operating system must be sized is explained in this. And the next note 2009-879 explains guidelines for sizing Red Hat Enterprise Linux for SAP HANA installation. And SAP note 1736975 explains about sizing of BW product on HANA. For installing BW product on HANA, what sizing measures do you follow is explained by this. And next is 1872170, which will explain about sizing for business suite product installations on HANA. This is the first SAP note mentioned, which talks about sizing SAP in-memory database. So here they have mentioned some information about SAP in-memory appliance, where definitions and the advantages of SAP in-memory is written as a whole. Coming to solution part here, you see that the recommendation here given is to follow the quick sizer tool for sizing the hardware. Quick sizer is a part of service marketplace again, can be accessed using this URL. And coming below, this section explains about the sizing of SAP HANA in-memory database as a whole. There is a sizing guideline provided in this SAP node. This attachment will give certain guidelines for sizing the hardware, which must be gone through. And how do we determine the data footprint of the data? For example, how do we determine the amount of data that is to be stored in memory, the amount of disk space required? So all that is explained in this. And if, for example, if we are migrating an existing SAP solution running on any of the traditional databases to SAP HANA, there are certain scripts included in this SAP node. For example, this script for DB6 and this one for Oracle. So these scripts can be executed, and after execution we will have results with the table size.txt with the result where it shows table names and their respective sizes. So that can be referred for proper sizing of the hardware to decide on how much memory is essential for running the solution which is going to be migrated to SAP HANA. So likewise, for different databases, the recommendations are mentioned here. Uh, Necessary scripts are included in this, and necessary SQL commands are provided in this so that we can fetch the information and then plan accordingly for sizing the target hardware. And next is about CPU sizing. We know that from sizing we mean to size RAM, CPU and the hard disk. So coming to CPU now, yes, for CPU again the recommendation is to follow the quick sizer tool, where there are three categories like easy, medium, heavy, based on the amount of data, based on the number of users. Classification like easy, medium, heavy is made in the increasing order. So overall, this SAP node will help us analyze and decide on what sizing suits the SAP HANA appliance implementation. So this is the PDF which I was talking about, and yeah, this zip file contains all the scripts explained above. Well, that was about explaining the first node where we decide on how to size the SAP HANA appliance. Moving on, let us now study about the quick sizer tool. By quick sizer, I mean it is the SMP quick sizer, service marketplace quick sizer. It's basically a web-based tool which is designed to make the sizing of SAP Business Suite solutions. So the result of using quick sizer is to calculate the number of CPUs, amount of memory and the disk size required. As explained, this is the URL where we have to navigate, and after navigating we will be allowed to choose two versions: Classic, HANA. Classic is for non-HANA databases, HANA version is for in-memory database, that is HANA. So we have to choose the HANA version here and furnish the required details, where we will have to provide the customer number, the product details, and the sizing can be done based on the amount of data or the number of users, and the end result will be of this format, where it will display the number of CPUs that has to be used, and amount of memory and amount of disk to be used in MB and GBs respectively, and also mention the computing unit performance called as SEU performance category here. What category class should be considered? For HANA, the solution is to choose AAA SEU performance. SEU is nothing but single computing unit performance. So with this result, we can then proceed ahead to size the hardware. Okay, number of CPUs, amount of main memory and amount of disk to be used for installing a HANA appliance. And moving on, SAP has designed a concept called t-shirt sizing, where for different levels of implementation or for different scenarios, different t-shirt sizes will be used, ranging from XS to large. Different combinations of number of CPUs, amount of main memory, amount of disk size is decided upon and can be leveraged whenever a HANA implementation has to be done. So based on the scenario and based on the environment we are working, we have to design this t-shirt sizing. There's no standard sizing picture available. Based on our implementation environment, we have to design such t-shirt sizing for easier implementation going ahead. One sample example would be where this picture shows about small, medium, large implementation. So a basic formula what has to be used, the recommended one for sizing CPU and storage is as follows. CPU to memory ratio should be 1:16 GBs. Like for every one CPU, 16 GB of main memory should be there. That's the basic formula used. And coming to storage, storage is where the data and the log areas are stored. That should be 4 times the total memory required. So by total memory we mean the amount of data that is to be kept, amount of productive data of the solution to be kept. So it is 4 times. So of these 4 times, the division goes like this. For data area it is 3x and for log area it is 1x. How? Why data area needs 3x? Could be a question. Data area would not only contain the actual data, it would also contain a data export or some set of executables. So of this 3x, 1x is reserved for the actual productive data, the persistence data, and another 1x is reserved for probably taking some sort of exports of the database, and another 1x is for storing some executables which can be shared across multiple servers in case of a multi-node system. By multi-node we mean multiple hosts combined together to act as a multi-node system, a single system, but with multiple hosts for achieving better performance or for load balancing. There are multiple advantages of having a multi-node. We'll come to that later. So for having a set of executables which can be shared across multiple hosts, one edge size is reserved, and log size is always equal to the total main memory required, that is 1x again. So in the small picture you see that for small category we need 16 CPU cores and memory is 256 GB. Based on this formula, this sizing is calculated. In storage again, based on this formula, storage is calculated 4 times the main memory. Accordingly, for medium, we have a similar formula implemented where we see 32, 512 GB and 2 terabyte storage. And large, again 64 CPUs, 1 terabyte of main memory, and 1 into 4 times 4 terabytes of storage. So using this formula as a base, you can decide on the sizing requirement for your environment and prepare a t-shirt sizing recommendation which can be used at any point for any sort of HANA implementation. Now coming to step 3, which is about hardware check. By hardware check, again it means checking the hardware before we perform the installation. So here we check the hardware configuration using a check tool which acts as a framework that provides tests and reports to determine if the hardware which we use would meet the performance criteria required for SAP HANA to run in productive use or not. And also this hardware configuration check can give us information about any problems that would be present in the hardware which can result in a failure of HANA implementation. So by knowing this result beforehand, we will be able to avoid any unwanted issues during HANA implementation. So to perform this check, there is a check tool, as I say, which comes as a part of a SAR file. No doubt, now this hardware check is implemented as an automatic check along with the HANA installer. The HANA installer like HDBLCM that we use for installing HANA database server already has this check in its algorithm. So before the installation is executed, such configuration check is performed. Only if the result of the check is positive, installation will be proceeded. Otherwise, the installation aborts, saying there is a failure of hardware configuration check. Before we run this configuration check tool, there are certain prerequisites recommended that must be present. So we must make sure we have the library NUMA1 version 2 installed on the server already. Second check is we should make sure open source network measurement tool IPOV is already installed. Third is that should make sure we have already exchanged SSH keys between different hosts to be used in the installation. And last one is that we have to make sure all servers have a resolvable FQDN. FQDN is fully qualified domain name. And we need to have a binary file SAP CAR called SAP CAR, which is needed to extract the hardware check tool binary to a SAR file. Using SAP CAR -XVF option, we extract the SAR package, and the location where we download the package, the hardware check tool package, is given here. You should go to download center in service marketplace, choose support packages and patches, go to index H under installation and upgrades, choose the platform edition of HANA, and go for compliant software component versions, and there you have an option to choose SAP HANA hardware config check. So under that you will find the SAR file, or other option is that the software installation package for HANA platform edition what we download also can provide this hardware check tool SAR file. So once the HANA package is unpacked, we will get data units directory. Under that we will have SAP HANA HWCCG directory, under which we can find this SAR file as well. So once the SAR file is provided, we will have to extract it using this option as I say, and we will have this new directory created. HANA shared HWCCG is created. Make sure all necessary permissions are there for the files under this directory, and within this directory we will have a Python script called HANA HWCheck.py, which is responsible for running the check. So in this directory, using the option Python HANA HWCheck.py command, the configuration check will be executed and the result will be displayed. So based on the result, you can proceed, otherwise do the necessary corrections. As said earlier, this check is now automated to be a part of HANA installer itself. So there is no need to exclusively run this step unless it is very much necessary. Now let's move on to step 4. Step 4 talks about file system preparation. As you all know that for doing any installation, we should have the file system ready. File system where we store all the necessary installed files. It could be executables, it could be instance files, it could be data area, log area, backup files. So for all this, we should divide the volume that we have, the hard disk that we have, into multiple file system mounts so that we can segregate the data for easier access. So what are the necessary file system layers that we need? First one is HANA shared SID, where the instance will be stored. Next is USR SAP SID, again where the standard way of storing the instance from traditional SAP system installation methodology. This is a standard mount where the instance gets stored. So this mount is also necessary for that. And next is HANA data SID, where the data area gets stored in the form of data volumes. There will be different data volumes for different services of the HANA, different components of the HANA, which will be stored under HANA data and the SID. Next is the log area, HANA log SID for storing the log area, where the appropriate component log volumes will be stored. From logs I mean the redo logs. Okay. And finally, a mount for storing all the backups. For safeguarding the data from persistence layer, we have to trigger regular backups which will go to this mount. So from this mount, then we can move it to a third server for keeping this data in a safe location. Could be on a tape using different techniques that we have, supported vendor techniques that we have. We will move this backup to another server called backup server. So that was about file system preparation. So we have to make sure we partition the hard disk to create all these file systems and make sure all these file systems have the necessary permissions so that we don't face any issues during the installation. So to do this, server management expert, like in simple terms, a Linux expert, operating system expert in the team can help us in getting this done. Next is about getting the installation package. Yes, now we have the hardware ready with proper sizing, file system, hardware check is done. Yes, now we can download the installation package for proceeding with the HANA database server installation. So again, we have to go to service marketplace. This is the URL to the service marketplace, that's software download center. From there, you have to choose installation and upgrades. Choose SAP HANA platform, that is SAP in-memory SAP HANA. Under that, you have to choose HANA Platform Edition and HANA Platform Edition 1.0. So there you will get the packages for particular release that you want. Could be support package stack 7, 8 or 9, where 9 being the latest available in the market. Download all the packages. There could be 3 packages or 2 packages for that particular support package stack. Download them, unpack them so that you will get all the subdirectories. Subdirectories would contain the necessary installers for only the database server, or installers like HDBLCM, SAP going, and installers for Studio, installers for client libraries, installers for additional apps on top of HANA like LC apps, EPM, Shine, AFL. So all the directories will be in this stack. You can directly use them, run the executable and install the required apps once the database server is installed. So firstly you have to install the database server, then only you can install all other apps on top of it. Okay, so now till here we have understood how a prerequisite check has to be done. Okay, once the prerequisite check has been done, we will proceed ahead with the installation. For installation, we will first have to log in with user root. Log into root shell. Just verify the file system. Again, to repeat the hardware check as a whole, and navigate to the software package downloaded directory where the software package is unpacked and where we have all the subdirectory, and from there we need to run the installation tool. So now let us study about installing the HANA database server installation, standalone HANA DB installation. Okay, so once the package is downloaded, we have to navigate to data units HDB server, and this installation is on Linux operating system, Linux x86 64. So navigate to this directory and we have to start the installer from the start. And the installer, the basic installer that we will be using is HDBINST, called as the HANA DB installer. So just issue /HDBINST, and this is the kind of screen that you will get. It will first show you the database installation kit detection information, the release what you will be installing, and then it will query you for a set of inputs. First input will be the installation path. You have to choose the installation path where exactly the installation has to be done. So by default it is HANA shared, but you can customize it as per your requirement. It could be USR SAP also, as I said in my previous explanation. So after providing installation path, next is you have to provide the SID. HANA DB gets installed as an instance. That each instance has an SID, a system identifier. So you need to provide the system identifier and then provide the instance number, the unique instance number. By default, it will take the next free instance number. So in any server, first free instance number will be 00. If 00 is not free, it will look for next free instance number, and that will be prompted. 00 is not available. Otherwise, you can go with 00 or customize according to your name. You can provide any number of your choice. This will be the instance number of HANA DB instance in this server. Next, you will give the data volume location. You have to choose a location where data area has to be stored. And accordingly, for log volumes, you have to choose a location where log area will be stored. And after all this information is furnished, you have to know that installation will create a standard admin user called system, which will have all the admin privileges on the HANA database. So this user gets created during installation, and the password for which will have to be provided by us. So give us strong password with a combination of uppercase, lowercase, numerical and a special character, and 8 characters is the minimum length, and reconfirm this password, and then it will ask you for an option where you can enable restarting of the instance if the server gets rebooted. You can choose yes or no for that, and after that option is provided, yes, the installation starts. It will check the installation, prepares all the packages. These are the standard packages what it will install, like CPU staging, Python support, runtime, binaries, installers. So all this that configuration files, and then extracts the software and installs them. And then it creates the system, starts the HANA database, and there are some standard delivery units which will be provided with every support package stack. Those will be imported into the database. Finally, once the installation is done, the log file of the installation will be created in this location. The location directory is var/tm /var/tm, under which you can find the installation log, and you can go through it for knowing more details. Now let us check in the server. Let us do a hands-on to understand how the installation is executed. I have logged into the Linux server. Command UMI shows which user I am logged in with, that is root, and df-h will show me the file system preparation. So the hardware check is already run on the server and it is positive. And as I said, we need to prepare these file systems. USR SAP HAN will be the SID which I will be using. USR SAP SID, that is USR SAP HAN, will be the instance directory. HANA data HAN for data area, HANA log HAN for log area, HANA shared HAN again for the instance directory, and HANA backup HAN for storing the backup. So this file system is already prepared, and next step is we can navigate to the installation package, which is unpacked, and run the installation. This is the installation package directory. We have unpacked the installation package, and these are the packages that we get as a part of the support package stack. and this is for SPS 8, and these are the packages. As I explained, we have packages for installing the HANA DB server and HDBLCM, as I explained, is also available here, and HANA DB Studio client as well for different platforms where the client and studios are supported. To know that Studio is supported for Linux as well as Windows, and client is supported for multiple operating system platforms: Windows, Solaris, OS 400, and Intel. For Excel as well, we have Linux, AIX, HPUX, and apart from these, as I say, we have hardware check package as well under this. The SAR file will be under this, and additionally we have application packages, that is apps on top of HANA to be installed packages as well, like LC apps, EPM, INA toolkit, Shine, AFL, River, File Load, and many others here as well. And we will have SWPM package also, which is an installer again for SAP installations, and HANA LM Lifecycle Manager, which will be explained later. Now let us proceed to install the HANA database server. I will navigate to HDB server Linux operating system. List the subdirectories and the files. Yes, these are the installers as I explained. HDBinst is an installer, and likewise we have other installers like HDBLCM, LCM Guide, HDB Setup, and this is the upgrade tool, and this is the uninstallation tool. These four are the installation tools, and this is the uninstallation, and this is the upgrade tool. Now let me run the installer HDB and apart from HDB and HDBLCM is another installer, but the advantage with HDBLCM is that it allows us to install multiple components. By multiple components, I mean it allows us to install database server, client, studio, and few other apps in one shot, whereas HDBinst installs only the database server. Let me come out of this. I shall explain you HDBLCM as well. See, as I told you, HDBLCM will install all these components, whereas HDBinst would install only the first component, that is the SAP HANA database server. So HDBLCM, apart from this, would install AFL, LC apps, client, studio, smart data access, and HANA LM Lifecycle Manager as well. This is more beneficial. Let me proceed with this. So I will select to where we are going to install new system. HDA is an existing system on the server which is already present, and it is currently stopped. Now let us proceed to install a new system. So I choose the option 2. I say enter. It takes a while to load. Okay, this is what I explained. See, here you can choose to install all components, or you can choose to install only the database server, or you can choose individual components also, like Studio, HLM, Client, AFL, LC App, Smart Data. So basically, in general practice, we first install the server, and based on the further requirement, we will install Client, AFL, LC App, Smart Data, HLM, if required at all. Otherwise, we will just keep the server. Now let us choose one. Since I need only the HANA database server to be installed. Okay, I choose the default values. Now I keep SID, HAN, which is the system identifier. As I said, by default it will take the minimal free instance number. 00 is the starting instance number. Since 00 is already taken up by HTA, 01 is prompted for installation. So I say yes for it. Just enter to choose the default value. Now next step is to specify what type of a system this will be. That is the system usage. So here by production we mean it's a productive system which will be used in real productive world. So it will have real data. And next is test. For any sort of sandbox testing, any quality assurance testing, test system will be used. So basically the productive data will be copied to the test system and any sort of testing can be done on top of it. Next is development system where new developments, new innovations can run. So there we choose development. Next is custom. So this will neither be a production nor test nor development. It could be a mix of all. It can be used for anything. Okay. Now let me choose 2 as it is a test installation. Okay. Next is about where we need to store the data area, the data volumes. So by default, it takes this location. As I say, so I choose enter and log volumes. By default, HANA log SI, that is HN. I choose yes to this option also. So next is about restricting the maximum memory allocation. Here we can specify a fixed amount of memory to be used for HANA database, or otherwise by default SAP HANA database will consume 90% of the RAM. So if for example 100 GB is the RAM allocated for the server, SAP HANA database by default will take 90 GB. So if our requirement is not to give 90 GB, we can custom set this value, say for 80 GB, or maybe we can set to a value above 90 GB as well. So in this I will keep the default value as 90%. So I choose enter, and next is it will ask for the certificate hostname. It will create a set of certificates for authentication and hostname has to be assigned to this. So HANA OS is the virtual operating system name which is assigned to this IP. So we will choose that now. And yes, an admin user at the operating system is SID ADM. Here it is HAM ADM will be created during the installation, which will have admin privileges at the operating system level. So admin privilege for accessing all the files, altering all the files will be owned by this user called HAN ADM. In general, SID ADM. So we need to specify a password for this user as well. It should be a strong password with a combination of uppercase, lowercase, numericals and special characters. Reconfirm the password. Okay. Now it has accepted the password. So this user will be created with the password that we have entered. Next is it will create a home directory for the instance. So HAN, which is the SID which is going to be installed, will have a home directory. The system will have a home directory. The standard one is USR SAP HAN home. I choose the default value. So next is about the shell, the login shell. You know SH, CSH, CSH shells. So I choose SH as the default shell, and user ID for the admin user 1002, and the time zone, the universal time zone. And next is the database admin user. As I explained earlier, A database admin user by name system will be created, which will have all the database privileges on the HANA database. So you can do any sort of configuration changes using this user, and can drive upgrades, can install apps. So varied amount of activities can be done using the system user. So this system user gets created during the installation, and for which we need to provide a strong password as well. Okay, once the password for the system user is provided, next, as I said, it will ask whether the instance has to be restarted whenever the server reboots. Could be some unplanned reboots due to some issues, due to some crash at the hardware side. Then the instance automatically gets stopped. So when the server is rebooted, that is restarted again, we can specify for automatic restart of the instance as well. So I choose yes for that as a safety measure. Then enter this value, and now it will give a summary of the execution. So here we can just verify our inputs of the installation path, the system ID, SID, instance number, system usage, test system, location for the data volumes, location for the log volumes, what we have specified. And the host name, what we are going to use, certificate host name, system administrator home directory, that is HAN ADM user home directory, the login shell of the user ID of the user group ID, that is always a part of SAP search, and the time zone of the user, and an option whether to have an automatic restart if the server is rebooted, and the software components that will be installed. So here, since we chose on the SAP HANA database server, it will show the version that will be installed and also show whether other components are specified to be installed or not. So upon verifying all these details in the summary, we can choose to continue the installation. So say yes and then enter. So now it will proceed to install the SAP HANA database server. It will install all the necessary components in this. And this installation would take quite some time, and also it depends upon the server speed, that is towards the network speed. And once the installation is completed, as said earlier, the log file will be available in the location /var/tmp. And make sure you see the message of installation as successful. So with this, once all the packages are installed, this is the kind of information that you will get, saying installation done, then see the log file for more details. Now let us move forward to learn about other installation tools as well. Next one is HDBLCM, also termed as HDB Lifecycle Management Installation Tool. So as I showed you the installation packages that we get, we have a directory called HDBLCM there, which will give the HDBLCM installation tool. And also under HANA DB software, that is HANA DB server software package, we will have HDBLCM as shown earlier. So to navigate only to this particular package, you have to choose data unit, HDBLCM, and the operating system directory. There you can find the HDBLCM installation tool. I have already explained about the differences between HDB-INST and HDBLCM. So to run installation, what is the command that we use? So we have to run the installation using /HDBLCM, give a space, double hyphen, action is equal to install. for installation. So then the interactive installation starts, or you can just mention /HDBLCM and then you can continue with the installation from there. Just issue HDBLCM with / option and then it will show you the same picture as shown below. It will allow you to choose what components are to be installed, whether only the database or do you want to install any other apps or the client or the studio or the lifecycle manager. Just proceed with the options as explained earlier and it will complete the installation. So in the same way STB-INST would also work, but STB-INST would just install only the database. It will also ask you for the same set of inputs as we saw with HDBLCM. Our next installation tool is HDBLCM GUI. This is again a part of HDB Lifecycle Management installation toolkit, but with GUI option. So here again you have to navigate to the same HDBLCM package under data units and you will see the installer file called HDBLCM GUI. This offers the user interface. There is no much difference between HDBLCM and HDBLCM GUI apart from the GUI what you will be getting, where you can just enter the inputs and monitor the installation. So you don't have to run it on the server as a command, but just issue the command and then rest everything happens on a graphical user interface. So as seen here, there are multiple options like interaction mode, which is the default, can be done using LCM, and batch mode is possible with HDBLCM, but batch mode is not possible with HDBLCM GUI. See, for installing the HANA database, now you got to know about the tools that we can use, but there are two modes as well. One is called the interactive, other the batch mode. Interactive is where you can interact while the installation is running, whereas batch mode is by providing a configuration file and the installer reads this configuration file and performs the installation. So we don't have to monitor the installation in that case. That means we don't have to interact with the installation. The installation runs on its own using the configuration file as an input file and does the installation based on the parameters and the values that we have specified inside the configuration file. So next option is about this automated installation, that is the batch mode of installation using HDBLCM shown here and a config file. So basically, to summarize, interactive mode is possible with both HDBLCM and HDBLCM GUI, but batch mode is possible only with HDBLCM. So this is the sample configuration file hana_install.cfg, and this is how it would look. You have to provide the SID, the instance number, and the user group ID in the same order as mentioned here. There are some more values what you can mention. You can mention all the values, like for example the user passwords and the installation path, the data volume, log volume path, everything can be furnished in this hana_install.cfg configuration file, and you have to run the installer by feeding this configuration file using the --config file is equal to the path of the configuration file. So run this command .hdblcm with --config file is equal to hana_install.cfg file, and it will do the installation in an automated way in the batch mode. You don't have to intervene, monitor it, but it will do the installation, and then you can monitor or check the log file which is stored under var.tmp for any probable issues that could have arisen. So with installation, we will get the data and log volumes created. As I explained earlier, there are different data and log volumes created for different components, different processes of the HANA DB. For HDB name server is HDB001. For Access Engine it is 2, Statistics Server 3, Index Server it is 4. Likewise, log volumes would have the same naming convention, but under the data and the log area respectively. So under the data area, we will have MNT 00001 as the parent directory for the data volume, and similarly for log volumes we will have the same naming convention. So this is for one host. In case if we have multiple node system, that is multi-node system with multiple hosts, for first host we will have MNT 00001, for second host we will have MNT 00002. So accordingly the volumes, that is HDB volumes for different processes according to the multi-node convention, would be present in the appropriate parent directory. Note that in a multi-node system there would be only one statistic server and only one access engine in the entire system. Okay, that would probably be in the first host installed. So from second host we will just have the name server and the index server data and log volumes respectively. Okay, apart from data and log volumes, we will have to verify the HANA DB profile. HANA DB, as we know, is created as an instance with an SID. So each instance in SAP terminology will have a profile, a system level profile, and the location of this profile is like this: USR SAP SID sys profile. This is the naming convention of the profile: SID, HDB, instance number, and the host. So navigate to this location, check for the permission of this file, and read the contents of this file, of the profile, to understand what are the parameters that it will have. Next is, there are some property files, also named as INI files. So there is something called as system local properties and system global properties, and the location for both is different. System local properties will define properties locally for the system. It's not, say for example we have a multi-node system where there are multiple hosts. Local properties will specify host level parameters only to that particular host what are the values specified, whereas global level properties will have global system global values, which is globally applicable for all the hosts, that is for the entire system, whereas local properties is only for this particular host. That's why it's stored under the directory host. So there will be such property files under each instance of each host. Say for example in the first host we will have such file host 1, and host 2 will again have these set of files. Whereas coming to global, this will be a shared directory across all the servers, all the hosts, and these files will exist as one for all the hosts, be it host 1, host 2, host 3. So it is globally applicable for the entire system, that is principal words for all the hosts. So coming to local property files, we have daemon.ini, log, SAP profile.ini, TMP, trace, wdisk, work. So all for different usage. SAP profile.ini will have the properties of the instance, local instance. Log will have some logs. Log will show some logs created. Daemon will have information about the services that are installed, the processes that are installed. TMP will have temporary files. Traces will have traces. wdisk will have some configuration files. Work will have the logs. Again, some working logs. Trace will have all sorts of traces in HANA DB. Coming to global properties, global.ini. Each INI here, global.ini, index server.ini, name server.ini, statistics server.ini will have a set of parameters which are grouped into sections. and are clubbed under each INI. That we will learn later. Okay. So once the installation is completed, we will have to navigate to these directories to read whether the data volumes are created, log volumes are created, hmm, profile is created, and whether we have the local properties files, global properties files. So we need to verify all this, and then we can proceed with the post installation steps. As I said, after the installation, we have to log into the server just to verify whether the instance, the executables, the data volumes, log volumes, profiles, configuration INI files are created or not, and also whether the HANA DB is running or not. So